Okay, we can now start the second notebook of our week, the data download and processing. You see that we are here in the course website. We go now to the new notebook. So here we are going to download and process the neuroblastoma data frame from the R2 database. Let's start talking about the R2 database. It is a platform that can be freely accessed online, and it is used for genomics analysis and visualization, where we can analyze a large collection of public data, but also some private data sets. So R2 is a database, and it stores genomic information and extensive tools that can be used to analyze and visualize the data sets. In the notebook here, there's a link to the R2 database. You can see here what it looks like. For example, I can try to access survival data. There is whole genome sequence, whole exome sequence. There's also UMaps, time series, and more data there that we are not going to cover today. I just wanted you guys to see where I downloaded the data that we're going to be using today. So let's now start loading. Let's move on to the part 2, loading the neuroblastoma data frame. So I downloaded R2, I downloaded data from the R2 website. It's in the data folder. The data that we're going to be using today is this R2 underscore GSC 62564 dot RDS. RDS stands for R data set. And you can see that I loaded that data in the data folder in the Bioinformatics Bridge course 2024. Okay, the next step that we're going to do is we're going to load this RDS object in we can calculate how long it takes R to load this object, and I provided you with the command for doing that just here. There are some notes here that you can read the notes. So there's also the link here for to the folder. I already showed it here to you. You guys should have permission to access this data. If you do not have permission, just let me know. Actually, I'm going to check here which sort of permissions I am giving. Anyone with the link can see the data. So I hope that this is giving everyone access to the data. So what I'm going to do now, I'm going to open the R console. At some point, I'm going to switch to R Studio, but this is only our second notebook. So let's stick to the R console for now. So as I said, ideally, we should write letter by letter of each line of code. But for the sake of time, I'm copying here. So the start time, this is not going to work because I'm doing line by line. So right now R is already counting what the start time was. It complained here about the location of the file because I did not set the file. I did not set the working directory, just as I did in the previous video with the chromosome 4 data set. So I'm going to again have to set working directory. Let's see if I'm going to remember the location now. So it should be desktop, Poliano. Let me think here. It should be Combio, I think. Combio Scientific. And then the book English. the recombile, I think, is going to be, now it's the 6. And then data. What is it called? It's the R2 underscore. It's called R2. You need to download this data set in your machine, and you in our in the R console, you are going to declare what the working directory is going to be. And I need the directory. I do not need the file, so I'm going to set the directory now to this data. So it did set the working directory, and now end time. And now I'm gonna do end time minus start time. How long did it take? Almost 2 minutes, 1.95 minutes was the difference between this line and this line here. So if I do it all together, it's going to give me an error again. It did not give me an error. And what is this object? Let's see. I thought that, okay, so it's not giving an error because it's looking upstairs and it's data. And okay, so when I did it like this, when I copied it entirely, it only took 2 seconds to do the commands, to do the operations. All right, so let's visualize the data frame now. Let's use the head function. We spoke about the head function yesterday. It allows us to visualize the first lines of a data frame. In this case, we want to see the R2 underscore GSC, blah, blah, blah. So you can see here that if I do not specify how many lines the head function is going to show us, by default, it's going to show us 6 lines. So I'm going to specify now n equals 20 is what I did in the notebook. So you can see here that it is showing to us the first 20 lines. So let's take, okay, so it started here, I can see, but I cannot tell what the very first column is. Okay, here. So this was the command that I typed. This is the first line, second line, blah, 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 20th line, okay? So this V1, V2, V3, these are, I'm inclined to say that they are vectors, that you can understand this as a vector, but I'm not entirely sure about that. So I'm gonna say it's a column for now. It's a column, and you can see that the first column has these words: Hugo, age at diagnosis, death from disease, EFS, INSS stage, progression. And then in the line 17, and this number 17, I think it's going to be important because it marks a transition from the lines of words to the lines of genes. These are genes, and they're measuring expressions, okay? So again, we are looking at the 21st lines of the R2 data frame, okay? And we are seeing what are the first 17 lines, and so this is the first column, the V1 is the first column, the V2 is the second column, the V3 is the third column. I want you to note that the first column, there is this word here, H colon Hugo, and then there's this word probe set, and then there's this word GSM 1205238. I want to tell you that this is an identifier of a patient. Okay, GSM, everywhere that you see here is an identifier for a child, actually, or the tumor of a child. Remember, this is a neuroblastoma data set, okay? This is an identifier for a tumor of a child. All right. So you can see here in the notebook all of that I showed in the console. In the notebook, I believe this is also true for you. You can also check what the columns are. And the reason why there are 501 columns, well, I can tell you that there are 498 kids tumors in this data set. So there are three extra columns, And let me see if I can identify what these columns are going to be. We go all the way back. So 1, 2, and it seems like I don't know if maybe the 1, 2, 3 is a column. It's counting it as a column, but then the Hugo, the probe set, I don't know if at the end there is. Never mind, I am taking that back because there's other information here that is not making sense in my mind now. But the way that we can understand this is that we are seeing the 20 lines and the 501 columns here. So we can use the DIM function to understand how many lines and how many columns the data set has. So if I go, so I can type here ls and I'll know what is in the environment. And the object that we're looking at is this one object here, right? So what I can do is I can do dimension and then R2 underscore GSE. And then it auto completes, and then it's telling us it's 24,961 lines and 500 columns. So this 500 now makes sense because now this is going to make sense to me. So here it says for 501 columns, but here it's saying 500. So the one column, it seems like that this column does not count. So it is actually the 498 tumors of the kids, or 498 kids plus these two columns. Again, what I said is that the GSM IDs are kids tumors identifiers. Okay, so each column identifies a child, and then there are two extra columns. That's the reason why the dimensions here are summing to 500 columns. All right, let's now move on to part 3, processing the neuroblastoma data frame. Understanding the metadata part of the data frame, we will have to load this dplyr library. So copy it. Okay, I loaded this library. If you do not have it installed, you will need to install the library. So a metadata is a set of data that describes and gives information about other data. Okay. So you remember that I mentioned the number 17 because so anywhere that you start looking from the lines 1, 2, 3, blah 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 until 17, you'll see that up until 17 they are words. They are words, except for this here. Let me see up here. Let me see here. 6, 6, 6, 6, 6, 6. 20. Okay. But I'm going to have to say that this number is also some sort of variable. What I'm trying to say is that from lines 1, 2, 3, blah blah blah, until 17, they are all, these lines are data about the data. They are not the data. If it doesn't make sense now, it's okay. But I just want to explain that to you. So what we're going to do in this next line, we're going to take the first 17 lines to be the metadata. So I'm going to copy this here. So now we're going to create this metadata object. Okay, so let's see how many lines we have in the metadata object. We have 17 lines. So these 17 lines, they describe what the 498 patients are. Let's see if there's anything else that I can say here when we look at the metadata. So this is very big, you can see, because they are 500 patients. Okay, so we are storing the 17 first lines as the metadata, and then all of the columns, except for the first and the second, they are the information for each one of the patients. So for example, for this patient here and in 238, the age at diagnosis, how many days of life the patient had was 987. For this one patient, it was 1800, 600, 300, 500, 100. So this was a really young baby that was diagnosed with neuroblastoma. So it's 30 times what? 4? 30 times 4 is 120 days. 150 days is 30 times 5. So this is a 5 months baby that was unfortunately diagnosed with neuroblastoma. There's no and because my brain doesn't know here if this is transversed or the other way around. I hope that I'm saying that correctly. Okay, so that is what the metadata is. We just looked at the metadata, right? The 900, the 1800, 600, 300, and so on and so forth. Okay, so let's actually find that 150 days old baby. This one baby here, that's the baby's ID. Fortunately, this baby is very young, but they're what is that? I can't remember what favorable all means, but it's favorable. I remember seeing favorable. $150. Yeah, it's favorable, at least. No here means death from disease. So by the time that this data was collected, the baby had not died, fortunately. So EFS means event-free survival, which means how long the baby has survived without an event. So for the 100 and so this baby survived more than 2,000 days without an event. And the reason why this is so much larger than the 147 is because the baby was diagnosed at this age. This baby in 243 was diagnosed with almost 5 months of age. And it seems like they lived at least 2,000 days without the disease. And now that I'm seeing this ID here, I'm asking myself if I'm reading this data correctly, but at least I am explaining some things for you guys. Okay, So we already visualized this. And I put a note here that in the previous visualization, which means this one, the second column is repeated, which means, so we see here age diagnosis, they are the same. Basically, V1 and V2 are the same. And now what we want to do is we want to remove the second column because it's not, we do not need it. And you can see here that I am, so remember that the V stands for vector. Let's imagine that it stands for vector, and then I'm removing the vector number 2 using the select method of the dplyr package. And now we can look at I'm not going to type that in the console. You can see here that it was removed, right? It's V1 and then it jumps to V3 directly. Now, what we're going to do is so this one here, remember, this is not the metadata data frame. So I'm going to call this the gene expression data frame. So now what we are going to do is we are going to remove the metadata information from the gene expression data frame, okay? So I'm going to do that now. So let me take a look before let me take a look at the header here. I want to see where the names. So we need to remove the first column because it contains the names of the genes. So that's what we are going to do now. Sorry, we are going to do that after we give names to the columns. So here, when you see the columns here, they do not have names. They have the numbers for the columns. So now what we are doing now in this step is we're giving names to the columns. Let's see if this is going to show us something interesting. So I gave the names of the data frame to be the first column. And I'm going to type the head again. It's so what I just did, you can see it here, is that I just made the very first row that's given by this number here, okay? I gave the very first row, sorry, I gave the columns the name of the very first row. So this is the row 1. These are the column names. And what this command here did was it named the columns of this data frame with the rows, with the row number 1 names. I hope it makes some sense. So it gave the columns of the data set the row 1 names. And now is when we can remove this row here. Now we do not need this row here because the columns now are going to have names. So let me type that here. Now I can do the head again, and it did not remove. Why it did not remove? Oh, because that was the command to give names to the columns again. I'm sorry, I should have copied this one. Now I do the head command again, and now yes, we can go all the way up to see that we have now the column names, and then the second line is not composed of the column names as it was before, like here, for example. We had the column names, and then the first line had also the column names. Okay. Now, what we're going to do is we're going to remove rows that have repeated. And the reason why we are doing that, if it's not totally clear, it is because I know that if I don't do this, it's going to give me an error later. And we are going to have to use this library Magiter. That's why we're loading this library now. So we're going to remove the duplicated rows using this Magiter package. And so this function distinct keeps only unique rows from the data, and it is going to use this H:Hugo because that's the name of that's the name of the column that contains the genes names. So let's go back here. It's this column here. You can see that it contains the names of the genes, okay? Okay, so let me copy this, paste it. Let's take a look at the head. If I go all the way up, we will see that the columns is still here. Actually, it's hard to see. It's hard to determine whether the repeated genes here were removed. So we'll have to believe that the repeated genes were removed because that's what the notebook tells us. So now what we are going to do, the same way that we gave the names to the columns, we're going to give names to the rows. And as I said, this is the column that contains the gene names. So we are going to give row names using that column. So let's go back here. Let us, so that column continued there. What we're going to do now is we're going to remove that H:Hugo column. Let's look at the data frame. Actually, I'm going to do six. I'll do 5 to see if it, okay. So the reason why I am not seeing it is because I'm using the wrong data frame. I need to look at the distinct data frame, the underscore distinct. I need to fix that in the notebook. Okay, so in the distinct, in the distinct data frame, we do not have the Hugo data frame, just as the Hugo column, right? The very first is this number 5238, and then the 7570. So 5238 7570. We removed basically the Hugo column from there. Okay, that's it. Great. And then we do some other modifications here. Then I'm just going to copy these modifications and okay. look at the gene expression data set after the distinct method is applied. Okay, I need to change this. We did some modifications. I'm not entirely sure why I'm removing the columns. Actually, it is this chunk here that I need to, it is this chunk that I need to write a code. Let me check this data frame here. Okay, this data frame seems okay. Let me check what the dimensions are for this data frame. Okay, 24,443, 498 is their dimensions. Hopefully this is okay. So, but basically, regardless, we were able to do some processing on the data frame, and we were able to identify some features of the data frame that's going to be important for us. Now, in the next video, we're going to do the phenotype score calculation.